Right, today's video is on circumference and arc length. And yes, we've done circumference before, but it's a really good lead into arc length and helps us with arc length, so we want to review it for just a second. Circumference is the distance around the circle, so it's a length, it's a measurement, and the formula is 2 pi times the radius, or pi times the diameter. So let's practice finding that circumference. So on number 1, I gave you the diameter was 7. So circumference can be found two ways, either with the radius or with the diameter. So using the diameter, the circumference would be pi times 7, which our final answer would be 7 pi, and our label would be inches. We're going to have exact answers on everything, so you're not using your calculator and multiply it by 3 times or 3.14, the pi button. We're leaving it in terms of pi. Okay, number 2, we want to find the circumference. The radius is 5, 6, so our circumference is going to be, given the radius, the formula is 2 pi times the radius. I didn't multiply the first one times 2 because I was already given the diameter. Before you multiply, you can reduce, and then I'm going to multiply straight across the top and get 5 pi, straight across the bottom and get 3, and the label is meters. Okay, this says arc length, but it really is the definition of an arc right here. So let's review that, even though we just did it a week or so ago. An arc is an unbroken portion of the circle, and we know that if I write arc AB with 2 letters, that's going to be the shortest distance between the 2 points. But if I write arc ACB with 3 letters, that means I'm going to start at A, go through C, and end at B. So it's going to be this arc in here. So having the letters makes a difference. All right, so what is arc length then? Arc length is the measure of an arc. And I'm not talking about the degrees. We just got done doing the degrees. We're trying to figure out the length. So imagine this circle that I've got pictured here made out of string. And it connects, goes all the way around. And I cut the string at point A, and I cut the string again at point B. And I take that segment, this little piece of the string right here, and I straighten it out and put it on a ruler and get a measurement for it. That is arc length. So it's not the circumference going all the way around the circle. It's just a portion of the circumference. And we're going to figure out what the length is. So we don't want the whole circumference, we just want part of a circumference. And thinking about that gives us an arc length formula. So the fraction, the portion, is going to be the degree over 360. So that there's 360 degrees in a circle. So if it was 180 over 360, that'd be half a circle. So we want half of the circumference. So doing the degree over 360 gives us the fraction of the circumference we need. So it's going to be this times the circumference. All right, let's practice this and put this in action. Number 1, we want to find the arc length. So to find the arc length, it's going to be the degree, which is 45, over 360. So that's the fraction. And we want a fraction of the circumference. So we need to know the circumference. Well, if the radius is 5, the circumference would be 10 pi. All right, before we multiply, we want to reduce. It's always helpful if you can reduce vertically or at a diagonal. You just can't go left to right. And if both of these things end in a 0, it doesn't matter which one you do first, but if both of them end in a 0, you can just divide by 10 and cross that out. That's kind of nice. Okay, then what about 45 and 36? Is there a number that goes into both of those? Sure, 9 does. 45 divided by 9 is 5. 36 divided by 9 is 4. And now that I've reduced, now I can multiply straight across the top, and I get 5 pi. And straight across the bottom, and I get 4, and my label is centimeters. Okay, that's how we find the arc length, and we're going to practice that again. Let's take a look at number 2. Good. Got all sorts of issues here. I don't know why, but I already have it written out. So let's practice it from here. Okay, so the degree. Now right here it's saying find the arc length. It says of AB, so we know it's this arc right here. So the formula for arc length is the degree over 360. That gives us our fraction, and it's a fraction of the circumference. Of means times, so I wrote times, and then the circumference. Well, circumference would be 2 pi times the radius. So this one would be 16 pi. All right, if you get lucky, you can reduce vertically or at a diagonal. And if you get lucky, you'll have something on the top and the bottom, but the both ends in 0. So I can divide by 10 and cancel those out. Okay, what else is there? Well, 10 and 36 I can divide by 2, so that's 5 and 18. Okay, what about an angle? 18 and 36, I can divide those by 2 as well, so that gives me 9 and 8. Now that I've done all my reducing, I'm going to multiply straight across the top. 5 times 8 times pi gives me 40 pi. And on the bottom, I'm just left with 9, and the label is inches. All right, let's do one more of these. Now, be careful on this one. It says find arc ACB. So ACB, that means that I start at A, go through C, and end at B. So the degree of that arc is not 160 because 160 is for this part. So how are we going to get that other part? Well, we're going to take 360 minus 160, and that gives us 200. All right, so when I'm writing my equation, I have the degree 200 over 360 times the circumference. So circumference is 2 pi times the radius, which is 8. So that is 16 pi. Put it over 1, doesn't really matter. Before you multiply, you reduce. If they both end in 0, I can divide by 10. That makes that easy. 20 and 36 are both divisible by 4. Now we can check 9 and 16. Will that reduce any? Nope. So now I'm just going to multiply straight across the top. I have 5 times 16, which gives me 80. So on the top, I have 80 pi. On the bottom, I have 9 times 1, which is 9. And my label is millimeters because it's a length. All right, one more problem with this today. We want to find the perimeter. Now, we did some of these before we left on spring break when we were... we did similar problems. So anyway, it shouldn't be too bad. But perimeter, you're going to have to add up all the sides. Okay, so let's think. This length right here has a length of 4. Plus, this length right here also has a length of 4 because it's a radius. Plus, now I need this curved part right here. Now, this curved part is part of a circumference. So if it's not the whole circumference, it's a part of the circumference, it would be the arc length. So I could do the degree over 360 times the circumference. Well, if the radius is 4, the circumference would be 8 pi. So I could do that. Okay, so I could do 360 minus 90 and figure out that this is 270, so I could do 270 over 360. But if you know what fraction of the circle that is, you don't have to start at 270 over 360. That is 3/4. So I don't have to write 270 over 360 if I know that it'll reduce to 3/4. So if you know the reduced fraction of what section of the circle it is, you don't have to keep writing it all out. Okay, now we need to combine like terms. So 4 and 4 gives me 8, plus this reduces, gives me 6 pi, and my label is inches. That's it. Try it on your homework, and then we'll do more later.